Good morning. This is Mark Summers from Summers Technical Services. We're going to continue our little series here on making drawings for our beverage cooler project in our CAD/CAM class. So I went over the -19 drawing earlier, and I want to start talking about the -25 drawing and go through a similar process to show you what kind of important features I want to see you dimension. We had to dimension all the features to make sure that you can make the part based on the drawing, and show you some techniques to use to do that. So let's get started. So here's my version of the -25 part. You're going to be coming in from the top side and milling out to get the right diameter for the can, and then you'll be flipping it over and locating 4 hole locations so you can drill your tap drill and do your tap for your holes on the bottom side. So let's see what our drawing might look like. I'm going to start a new drawing, file new, and the part size is such that I think it'll fit nicely on a 1:1 scale on a B-size sheet. So that's the template I'll use. And once we get the template pulled up here, I got to figure out what view is going to be most representative of my part, and I think it's going to be the top view. And so let's find my drawing or my model over here. I'll double click and I'll ask for a top view when it lets me, and I'll place that view right here. So that looks good, and I want to make sure that it's using my sheet scale so that my title block updates automatically. So if I select the view, I can come over here to the properties, and I can see that yes, indeed, it's using the sheet scale. I want to find out what my sheet scale is. I can do it one of 2 ways. I can right click on sheet 1, go to properties, and it'll tell me it's a 1:1 scale. And I can also verify that because my title block pulls that data from the file and it knows it's scale 1:1, so that looks correct. Alright, so I need to also see a bottom view, so I want to do a projected view. I can flip it over here, similar to what I did with the -19 drawing. And there's a side view, and I'll do a projected view of the projected view and get my bottom view. And then I think I want to see a section view. Might be handy so I can see what those holes look like. So I can come up here and go ask for a section view. I'll get a section view going horizontally right through the middle of the part, and then place that down here. That might help clarify what those holes look like. And I can go in here like I did before, and first thing, get rid of this lame hole call out that SolidWorks throws on there by default, and move my annotation down a little bit, and I can change the crosshatch visualization here. So this is defaults. It shows the cross-section hatch, tries to represent the material. So rather than having that, I like to have some common normal 45-degree angled hatch. So I'm going to turn off material crosshatch, and I want to come up here and choose, I believe it's ANSI 31 or ANSI. There it is right there. That looks pretty good. Alright, so now let's talk about adding some dimensions on here. We need to first locate the datums. It makes sense to me to have the datum for the milling to be the top surface of the part, the top of stock. So I'm going to come up here to annotation, and I'm going to define the datum feature as this top surface. So I can scroll in down here and place datum A at the top. That's my primary datum. And place that over here. And then datum B, I'm going to define with a feature size dimension being this outside diameter. So I'm going to dimension this outside diameter in this top view. And there it is there. And I'm not sure why mine is 2.95, but yours, the raw material is 3 inches, so I think yours will be 3 inches. I think I machined mine down to make it nice and shiny. Anyway, this is going to be a reference dimension because that's part of the raw material drawing that we've created before. So I'm going to make this a two-place dimension because that's the tolerance on the material we're buying, and I want to make it a reference dimension by putting parentheses around it. Now I'm going to use that feature of size dimension to define datum B. And datum B will be the theoretical center of that cylinder, the diameter of that part. So I'm going to come in here and say datum feature. I want to tie it to this dimension. So I want to select that dimension, and then I want to place that datum over here. So now datum B is being defined by that diameter, that feature of size diameter of the part. Need to make sure I put center marks on all these views that need them. That one needs a center mark. That one needs a center mark. And these holes need a center mark. All the cylindrical features need to be indicated with a center mark. And in the side view, I need to do a similar thing. I need to make the center line goes to the middle of the part here. Okay, so you need to put dimensions for all these hole features and all the other features of the part. And I'll let you, what happened to my center mark? No, I don't want a center mark, I want a center line. What am I thinking? There we go. Center line halfway between that edge and that edge. All right. So I think we're going to want to use ordinate dimensions for these hole locations. So I'm not going to do all the dimensions. I'll just do a few of them. First thing I want to do is show, find this hole call out for this tapped hole. And so your tapped hole will be different depths, potentially different sizes, because you're designing your own part. Let me show you how to pull the drawing dimension up. So I'm going to go to model items because I want to pull the model note call out from the model. I've already defined that hole in the model. I'm going to extract that data. So model items, selected feature. I don't want it to import it in all views. I want to import it in the view I select. So I want to select this view. So now it's going to put it in that view, and then I just select the item I want to put the hole call out on, and there it is. And that's all the information for the tap drill diameter that you'll need when you drill the hole in your part to tap it, how deep you're going to make the tap drill depth, and the tap sole size as well as the tap depth. Now I don't need all these dimensions to be three places. This tap depth and the tap drill depth, I don't need those to be three-place dimensions, plus or minus 5 thousandths. I can live with plus or minus 20. So I want to come in here and select this hole call out, and I can individually change the tolerances on any one of those numbers. So here I'm going to use tap drill diameter. I'm going to leave that as three-place because I want to get a tap drill diameter within plus or minus 5 thousandths. The tap drill depth, I can make that a two-place dimension. And then the tap depth, I can make it also a two-place dimension. So that makes more sense to me, tolerance-wise. All right, so now let's put some dimensions on here to locate these holes. I want to locate these holes using a feature control frame to control the tolerance zone of the locations of those holes. So I need three things to do that. I need to have datums, which I've got. I need to have basic dimensions, which I'm fixing to have, and I need to have a feature control frame, which I'll do last. So when I do dimensions, I'm not going to use smart dimension. I'm going to use ordinate dimensions to try to save some space here. So I'm going to go ordinate dimension. I'm going to select the ordinate. This is the datum, so I'm going to select that as the ordinate. I place the ordinate, and then I place the dimensions I want to place. So now these are all grouped together, and you can see that they move together. So when I drag this one over, they all move as together as a group. Now it looks like I forgot to grab one over here for this other hole. So instead of making a new set of ordinate dimensions with a new ordinate, I want to add ordinate dimensions to this ordinate here. So I want to select the ordinate, right click, add to ordinate, and then I just select the other edge or the other center mark. Now those are all grouped together like I like. So you'll do the same thing for the other dimensions for the other hole directions. You'll obviously come in here and dimension these other features You're going to want to put center marks on the tapped holes. You can put reference dimensions on this tap depth just to kind of reinforce the fact of what the tap depth needs to be. So if I do that over here, between here and here, not letting me do it. What's going on? Smart dimension. I want a dimension from here to here. Well, that wasn't what I wanted. Let's try that again. From here to here. There we go. So I've already got that dimension up here in the hole call out. 313 is the tap depth. There it is right there. But if I want to show it out here just to kind of reinforce the fact that that's the tap depth of that tapped hole there, I can make this a two-place dimension and got to make it a reference dimension because it's already called out up there in the hole call out. So that would be okay to do that. So you add the other dimensions. Make sure you think about what the tolerances need to be on your dimensions. Most all of them are going to be three-place or two-place dimensions based on the criticality of the dimension for the function of your design. And what else do I want to show you? Make sure to fill out the material. You're going to reference the raw material drawings that you did. You're going to fill out the title block like we've done before, and fill out the revision block for a dash revision. This will be a dash revision when you turn it in to get graded. Okay, so now I've got, I need to show you how to turn these dimensions into basic dimensions. Since these dimensions are located in these holes, these need to be basic dimensions, so you can select them. Select the first one, control click, more dimensions, and I come up here to set a none on tolerance precision. I change it to basic, and it puts the box around it, which means that that dimension has no tolerance. It's not locating the hole per se, it's locating the target position for the hole. So now I'm almost there. I've got my trifecta in process. I got datums, that's 1. I got basic dimensions at 2, that's 2. Now I need to add a feature control frame to this call out here. So I do that by coming up here, go to geometric tolerance, and I can make the note, tie it to a feature with an arrow. I can click on the free space out here and make it a freestanding note. But what I want to do is make it tied to this call out here so they move together. So I want to select that note. It gives me the pop-up box there. And I can say OK. Now I'm going to double click on this, and it should start giving me options to start plugging in numbers here. I'm patient enough. Here we go. So I want to click, I think I click this button here, and it's going to start asking me for stuff. So here is the, I want to grab the characteristic. Not seeing it yet. I don't know why that text is so weird looking. Well, this is a bummer. Let's click on Add Datum. So I got my primary datum is going to be A. That's going to be the top of stock when I set it up on the milling machine. And I want to add a new datum, and the second datum is going to be B. And that'll take care of the datums. And so I'll say done. And see if I can get it to let me add some more stuff here. I got to add the characteristic, the positional characteristics. I'm double clicking on it here. A little bit confused about what this is asking for. Oh, wait a minute. Insert symbol. Nope, that's not what I want. Maybe I got to select one of these other buttons here. Nope. Nope. I tried that one. What is an indicator? What is that? Nope, I don't want that. I'm going to delete that. Why is this so hard? try again here, double click. Here we go. So I want the positional feature control. There it is right there, position. And then I want to double click here and get, or here it is, there's a number. You can type in whatever tolerance zone you want based on the design requirements of your part. You got to make sure that the holes line up to whatever tolerance you need. I need a diameter symbol in front of it, so I'll click there. So I think that's what I want there. I want a positional location within a diameter of 10 thousandths relative to A and B. And then I don't know what this thing is here at the end, but I need to delete it. So if I double click on it, and I just hit delete, oh, didn't want to delete the whole thing. Control Z to get it back. I'll have to figure out how to delete this. So anyway, minus that tagged on thing at the end, it looks like we've got what we want. All right. So maybe that's enough for now. So whoop, I double clicked on there. Let me get out of here. If you get that pink box around there, you just need to double click back out of it. So if I double click on the inside, it thinks I want to edit the title block, which I don't want to do. There we go. We got it back. Okay, so that's a good place to stop. So go ahead and get your drawing started. Use this as a guide. Make sure to fill out all the title block. Make sure all the features are dimensioned so you can make your part. And as always, if you have questions, you can ask them during class, or you can stop by during office hours. So have fun making your drawing, and we'll see you in class.